Hello and welcome to our video today, which is dealing with recycling plastics in medical technology. One of my favorite topics to talk about. It's kind of my specialty. My name is Pianegonda, and I helped over 30 plus medical device companies to be more sustainable with plastics. Let's just dive right into the topic, if my PowerPoint wants to. Yes, it does. Yeah, we'll skip that. So I have a bunch of credentials that you can pause the video and look through. And we are Gradical, and we help medical technology companies to choose the right plastic for their application from a cost, technical, material compliance, and of course sustainability perspective. What are we going to cover in this video? We are going to look at the sustainability trend in medical technology, and yes, there is one. It's probably the reason that you're here. And then we are going to look at the pros and the cons of recycling plastics in medtech devices. Then we are going to have an overview over recycling plastics, and then in the end we will see that recycling plastics actually already have an application, and so you have to stay until the end to get that. Good. So, sustainability trend in medtech. If you are going through the list of the 100 biggest medical technology companies on the planet, you see a bunch of them on the screen. Then you see that 41 of those already have an SBTI commitment, so a science-based target initiative commitment. Or they have already verified goals, meaning that these companies all have pledged to reduce their CO2 footprint and therefore pledged to be more sustainable in the future. And you would say, yeah, that's only like 41% in numbers, but if you look at their total turnover, it is, I think, 320-ish billion turnover. That is already committed, and that is a little more over 50%, 55 to 60% of the medical technology market that is already committed to being more sustainable. So, conclusion, yes, there is a trend for sustainability in medtech, and now we have to define what sustainability is, because the word sustainability has been bastardized to just mean ecology. Everybody's talking about sustainable plastics, sustainable this, sustainable that. What they actually mean is ecological, so better for the environment. But real sustainability means ecology, economy, and social aspects. Meaning, translating that into the medtech, we have good for the planet, yeah, ecology, good for our pockets, so it doesn't increase the cost unnecessarily. We're still making money with it. We still have money to invest, and then in the end, and that's the most important point in medical technology, is good for the patient. And sometimes I would like to strive for better for our patients, so as good as a patient outcome as possible, because patient in hospitals usually is not the most sustainable way. So if you can find a way for your device to help patients stay out of the hospital, that's even the most sustainable that you can ever be. And a holistically designed medical device needs all three pillars. So we do not only need to be good for the planet, but we need to be good for our pockets, and we need to be good for our patients. And the key here is that we cannot sacrifice patient safety for profitability or for environmental benefit. We cannot do that. However, it is imperative that we find a way to combine all three, and that's real sustainability. So, what speaks for using plastics, recycled plastics, in medtech? And I think around 10 years ago, I would have been booed off stage if I ever talked about this on a medtech fair or anything like that. But the number one reason why we are even considering to use recycled plastics is CO2 reductions in the future. Reporting and reduction will be a duty. and also for Medtech. Especially in Europe, Europe is extremely pushing for the Green Deal, and sustainability and material compliance basically will mean the same thing. So there is regulatory pressure to reduce CO2, and you will have to do it. Then the CO2 reduction from recycled plastics is great, since recycled plastics often have a fraction of the CO2 footprint compared to virgin material. And then recycling technology in the last years has improved massively, meaning that we are getting higher performance, less leachable, higher quality recycled materials. I think 10 years ago, that the reason why I would have been booed off stage, it was you could make like park benches, or you could make like flower, oh god, I don't know the word for that in English, like a piece that you can put your flower in. That's basically the joke that everybody does. Yeah, you can still make park furniture or something like that. So low quality applications could have been done, and recycled materials were basically only available in black, and they were stinking, quality was low. But that has improved massively. Like sorting technology has improved, washing technology has improved, like gathering of the plastics has improved. So that is really a very nice trend to see. And thanks to a lot of investments and of course the regulatory pressure, this will improve in the future too. So I see the trend of high quality recycled materials being available as a trend. And now the bad thing. What speaks against it? So number one, there is usually a trade-off between quality and environmental impact. So if you're looking at, that's a little spoiler for afterwards, chemical recycling, especially pyrolysis, has a high quality, like virgin-like. However, the environmental impact is questionable, and therefore you always have this trade-off. Either it's good for the environment, or either its quality is good. And that trade-off is really a challenge. Secondly, especially for mechanically recycled materials, the quality and risk management. That is a major point that has to be addressed, and as I will speak of later, not all medical devices can be made from recycled plastics. And there is where I think the title is a little clickbaity. I call myself out on that. But there are certainly devices, and I have an example later that we will see, where recycled plastics can be used. And then the regulatory requirements. And that is the question I get most often is, am I even allowed to use recycled plastics in Medtech or in my medical device? And here's what the MDR says about this. The MDR only knows the word material. So no plastic, no metal, no ceramic, no whatever, no recycled. It's only material. And this is in the General Performance and Safety Requirements, I think Annex 1. And you can read those 10 pages. And basically summarized it is, recycled materials do not have a separate requirement from virgin plastics, but they need to be as safe and as effective as all other materials. And it boils down to materials have to be safe and effective, meaning that there is no regulatory hurdle in using recycled plastics. This is the good thing. So regulatory doesn't tell you, or MDR doesn't tell you, you cannot use the recycled plastic for your devices. You just need to make sure that they are safe and effective. And now comes the bad part. There are technical hurdles to this. So it's difficult to get the mechanically recycled material, or to get recycled materials on par with virgin in terms of quality and risk management. And here comes one of my favorite slides and one of my favorite analogies. I always say that Medtech is between crutches and implants. So you have a crutch, so you broke your leg, for example, and then it helps you walk. And doing that with recycled material is, what's the worst thing that can happen? The worst thing that can happen is the crutch breaks and the patient breaks his leg again. which is of course bad, but this risk can be managed since the mechanical properties of recycled materials can be managed quite well. So you have an incoming good inspection, you test for mechanical strength, then you have in-process control, then you have outgoing goods inspection, and that can make sure that your crutches do not break, even if it's made from mechanically recycled material. And then implants, on the other hand, there is like a handful or maybe 2 handfuls of polymer suppliers, plastic manufacturers, that advertise their plastics to be implantable or that had special implantable grades. Usually those firms, those companies have a separate legal entity for implantable materials just in case that they get sued to death, so they can let the implantable materials business unit or legal entity die instead of the whole company. And they usually you pay usually like in the range or in the order of magnitude of gold. Like plastic is extremely, or implantable plastic is extremely expensive. I have heard from $10,000 plus in per kilo for such material, meaning that Virgin doesn't dare to go there. Most of Virgin doesn't dare to go there. Why should we go with recycled materials? So that will not happen. I do not advertise for making implanted implants out of recycled plastics, but crutches are certainly possible. And the question is, where exactly is the boundary where we can use recycled plastic? And that really a little bit also depends on which recycled plastics you're talking about. And in that case, we have to give you I have to give you an overview of what's available, and try to draw a landscape, let's say a recycled plastic landscape, in terms of quality and in terms of environmental impact. So number 1, on the top right, you have the chemical recycled materials, and those have a very high quality. They, however, especially for commodity plastics such as polyethylene and polypropylene, which are used a lot, there is the pyrolysis method, and the pyrolysis method usually uses a lot of energy, has a high environmental impact. So I always say that if you use coal energy to do pyrolysis, you could have burned the plastic and be better for the environment. And then we have the dissolution dissolution recycling in the middle, where you have a, let's say, intermediate environmental impact and an intermediate quality. Dissolution, for those who don't know, is like you dissolve a plastic in a solvent, then you get rid of all the additives, or you get rid of all the fillers using that, and then you precipitate the plastic out of the solvent, and then you have a hyper purified recycled material. Of course, you need to sort before, and there's a lot more to it, and it's not as easy as it sounds now, but it is a very promising technology. And then we have, on the other hand, we have the mechanical recycled materials, either post-industrial recycled materials or PCR, post-consumer recycled materials. And those, like post-consumer recycled materials, is usually, or post-consumer recycled mechanical recycling material is usually what you think of when you say recycling material. And that is why I basically triggered you into like all of those are not the same, and this one is the most challenging to use. The PCR material is the most challenging to use in the medical technology. And there you have a very broad environmental impact and very broad and let's say quality range, because it all depends on how contaminated it is, how much you need to wash it, how much you need to sort it. But in general, it's a low environmental impact, but also low quality. And then you have the post-industrial ones, where you usually use scrap in your production to be used as a raw material for your recycled material. And there you usually don't have the sorting problem, so quality is a little higher. On the other hand, the environmental impact is also very low, because you do not need to sort, to wash a lot, and therefore that's usually a very nice, high quality, low environmental impact choice. And then I also have like a bunch of arrows which tell you the trend. Chemically recycled material, I think there's going to be more efficiency. So the quality is on virgin level, but getting to a better environmental impact, that is where it's going. And I think Lionel Bazell has shown off some catalyst systems that can reduce pyrolysis temperature significantly. That is something. There are also a bunch of other technologies in terms of chemical recycling which can make the environmental impact a lot better. And then for the solution technology, the same. Better quality, better environmental impact. And in mechanical recycling, you have like the other trend. It's like you do more, you wash more, you sort more to get a better quality. And then in the end, you have to decide where your quality threshold for your medical device or your packaging is. And I think a lot of times it's possible to get a recycled material that is qualified for your devices. So sorry for the small cut. My 2-year-old just walked in and thought that he could crash the party. Moving on, mechanical recycling material in medical technology. That's the last slide we saw is this overview. And then we have the mechanical recycling material in medical technology. How can you use it? What are the most important points? And the most important points is, number one, you have to get your supplier on board. Like a lot of recyclers come from waste management. And I don't mean that in a derogative way or in a way that is like insulting, but it's just a fact. So they recycle fridges, they recycle cars, they recycle something, e-waste or something like that. And then they tell you, hey, I got polypropylene 99% pure. And then I ask them, okay, I need a specification, quality agreement needs to be done. I want to audit you. Please send me some certifications. And then they're like, what do you want? It's polypropylene. We don't know more. We don't know more about our material. And then that's usually the point where negotiations stop, because there's just no sense in it. So what they need to be able to do is you need to have a quality agreement with them, and they need to be willing to sign one. You need a specification. You need to know what you're getting, and they need to be able to at least limit some of the specifications, like MFI, like mechanical properties, like black spots or anything like that, so that you can work and live with it. And you need to audit them. And that's a very important point. Then quality and risk management. You need to do an incoming goods inspection. Usually I would advise to do also with biocomp, especially if you have patient contact. It's a good idea to have a biocomp, at least let's say cytotox or a chemical analysis in there. Then you need the in-process control, because the flowability is variable, and you need to make sure that your devices always come out with the same quality. And then the outgoing goods inspection. So you need to up your basically quality game. What you're doing with virgin material, you need to do too, but like up your game a little in there. And then stakeholders. The most important point is that you engage your management. This is not a project that you will be able to do like undercover as a new boat. You don't do that. You need to engage your management, and you need to have air cover basically, because you need to also manage expectations. It's not gonna be easy. You will have problems. There will be some material lots that may not be good. You need to learn your way and stumble your way up the stairs basically. And that can only be done if you have air cover, basically management support. You manage the expectations right, and of course you need to ensure the communication. The communication to the stakeholders, to the supplier, and also within your company. Because there's always going to be a person that has an opinion, and the opinion is that recycled materials shouldn't be used in medical technology, and then they will try to shut your project down. And that will be a pity. So then I have an application example. There's an otoscope tip. The otoscope is like used to look into your ear canal, or like into your mouth, and is used by many physicians. It's a very standard device for diagnostics to basically look into an orifice. And then you have these otoscope tips that are used that your bodily fluids do not contaminate another patient. And how did they do it here in this example? It's the otoscope tip is made from polystyrol, and they use 100% mechanically recycled polystyrols made from recycled fridges. And as you see this is a very limited waste source where you know it's a high quality and a constant quality, and you also have a good availability. Then it's an MDR class 1 single-use medical device that has a few seconds of patient contact, so biocomp is required, and I think it's a lovely example, and it shows that you can argue in your risk management that mechanically recycled material is safe. You just need to know how. And patient contact, I said that, only coming from the material, not like processes and transport and everything like that. Just the material has 75% less CO2 emissions than compared to a virgin plastic. So I think polystyrol has around 2, and the usual figure rule of thumb that you take for mechanically recycled material is 0.5, so 75% savings overall with that. And in conclusion, recycled plastics can be used in medical technology. The use is in its infancy. Jesus, that is a sentence. And has many hurdles, and we're not there yet, basically. But it is possible. And the biggest potential, in my opinion, lies in simple medical devices. I'd say low patient contact, short patient contact, simple medical devices with not the highest requirements in terms of precision and in terms of leachables and stuff like that. And we do not know where the limits are, and I think that's the thing that makes it the most exciting and the most challenging, and therefore I love the topic. So thank you for your attention, and that would be it for the video. This was a talk that I usually hold on conferences, so that's a sneak peek or a publicly available source for it. It's one of my favorite talks, and so if you're a Medtech company that wants to make their devices more sustainable while not increasing cost too much and risking compliance, there's a link in the description. I just mentioned that it's there. Full transparency, it's a sales funnel, and it will try to sell you something, namely our Great Match program that helps medical technology companies to be more sustainable with plastic. And it's there. I don't care if you go and click it. If you click it, I'd love to meet you, but it's there. And if you draw value from my videos, like, subscribe, like all the things that the YouTube algorithm likes. And if you post a question about the video, or you have a request on a new video, let me know in the comments, and I read all the comments. I try to reply to you, and I would say that will be it, and have a good one.